So with the first one, what do we know about the domain of a relation? The domain is which coordinates? The x coordinates. So 2, 3, 5, 3 again, I don't need to list that twice, so I'll just list 2, 3, and 5. The range is the y coordinates, so that would be, let's see, 7, 6, 4, and 2. Let me write those in increasing order, just because I like it. And is this a function? Now, I gave you 3 different definitions for something to be a function. Is this a function? No. Why not? Yeah, so you've got a 3 here and a 3 here. So if I asked you what value of y goes along with x equals 3, you'd kind of shrug and go, well, I don't know, could be a 6, could be 2. If you were to graph these, those points would be on the same vertical line, so it would fail the vertical line test. So you could answer a couple ways. Fails the VLT would be one of them, or each x does not have unique y. Each x does not have a unique y. Unique value of y. So something to that effect. Either one of those would be fine. Let's keep going down to the next one. So you're asked to graph this equation, y equals negative 2/3 x plus 4. I asked you for a couple things. I asked you for at least 3 points and including the x and y intercepts. So let's start with the easy point. If you set x equal to 0, you're going to get the y-intercept. Now, do I need to actually do the math here, or can I just see that the y-intercept is already there? If you plug in an x equals 0, you get a y equal 4. So negative 2/3 times 0 plus 4 equals 4. I need a couple other points, but one of them has to be the y-intercept. How do you find the y-intercept? Or so you can find the x-intercept. This is the y-intercept. How do you find the x-intercept?
Set x to 2.
So y equals 0 gives you the x-intercept. So if I set 0 here for y equals negative 2/3 x plus 4, let me move the 2/3 term to the other side. And the reason I'm doing that is because it gets rid of the negative. So that's nice. That gives me a positive 2/3 x equals 4. Now if I want to solve for x, I can multiply both sides by the reciprocal. So 2/3 x equals 4. What's the reciprocal of 2/3? 3/2. 2/3 times 3/2, those things completely cancel each other out. I get 6/6, which is 1. So in other words, I get x on the right-hand side, 3/2 times 4. Well, 2 goes into 4 twice. 2 times 3 gives me 6. So 0 for y gives me 6 for x. And do you remember the trick that I showed you to get a nice even point?
You divide.
You want to choose something that's, what was the trick there?
Denominator.
Yeah, you want to choose something that's a multiple of the denominator. So something like a 6 or even a 3. So if I set x equal to 3, then I can avoid having to work with fractions because I chose a clever value there for x. So I get negative 2/3 times 3 plus 4. The 3 and 3 cancel. Negative 2 plus 4 gives me positive 2. So 3 and 2. Now, if I did my work right, they should all lie on the same straight line. If they don't, you've made a mistake. So don't just draw a line or draw a triangle. Go back and figure out what went wrong. So we got points at 0, 4, at 6 and 0, and there should be one right in between at 3 and 2. And if you look at this, they all fall nice and neatly on that same line. So, beautiful. Let's stick with that line for just one more little bit. We've got the line y equals negative 2/3 x plus 4. What's the slope?
Negative 2/3.
Negative 2/3. And the y-intercept?
4.
It's 4. We can't do that with this one though, right? You got to solve for y first. So I'll move the 3x to the other side. When it gets to the other side, what's that 3x term going to look like?
Negative 3x.
Negative 3x. Is the slope negative 3 and the y-intercept is 4?
No.
No. What do we got to do first?
Divide 2 both sides.
Divide by 2 all around. So we get y equals negative 3/2 x plus 2. And now we can figure out our slope and our intercept. So what's our slope?
Negative 3/2.
3/2, and the y-intercept is 2. Nice. Let's flip things over to the backside. Write the equation of a line passing through 2/5 or passing through 10/3 with a slope of 2/5. So you want to use this formula: y minus y1 equals m times x minus x1. Filling things in. Here's my x1, y1. Y minus 3 equals 2/5. X minus 10. Don't be afraid to distribute this. The first part of it works out pretty nice. It's just 2/5 x. 2/5 times 10. The 5 is going to cancel into the 10 how many times?
2.
2. And then 2 times 2 is 4. You can also do that on your calculator, that's fine. If I add 3 to both sides to put it in slope-intercept form, I end up with 2/5 x minus 1 when you add the 3 to both sides. So, how many people got that one? You guys get that one right? Yeah?
I
Okay.
actually have a question about that one.
Yeah, please go ahead.
So for what I did is I kind of wrote it out already in the slope-intercept form where I had y is equal to 2/5 x, and then
Then you plugged in and solved for b?
and then I just used the 3 as the y-intercept. But that's not correct.
No. So another way you could do this one, if you wanted to do it this way, would be, and it's up to you. I don't have any preference. I kind of like this way better, but y equals mx plus b. You know that's the form of the equation of your line, and you know what the slope is. So it's y equals 2/5 x plus b. You just don't know what b is. So you do know that this line passes through the point 10 and 3, right? So that's putting in a 3 for x, or excuse me, a 3 for y, and a 10 for x. And so, let's see, 2/5 times 10, that's going to give me 4 plus b. Subtract 4 from both sides, I get b is negative 1. So now I can plug that back in here and get y equals 2/5 x minus 1. So it's a different way to solve this, but it gets at the same thing. So that's kind of close to what I think you were suggesting. Over here, kind of a similar problem to what we did here, except we got an extra step. Here we've got 2 points, but no slope. So what's our extra step for this equation, for this one? Find the slope. So your slope is y2 minus y1 over x2 minus x1. I'll just label these as x1, y1, x2, y2 to start with. You've got to be careful with the negatives here. It's negative 10 minus 8 over 3 minus negative 1. And it doesn't work out nice and even, does it? You get negative 18 over a positive 4. Since both of them are even, let me divide by 2 in the numerator and denominator and get a slope of negative 9/2. Let's pick either one of these points. I don't think it's gonna work out very nice either way, doesn't matter. So I'll just pick the first one and plug it into this formula over here. Y minus y1, that's gonna be y minus 8 equals negative 9 halves times x minus negative 1. So that's y minus 8 equals negative 9 halves times x plus 1. So y minus 8 equals negative 9 halves, x minus 9 halves. And if you're looking at that going, oh, now I got to add negative 9 halves and 8, you're right. But if you don't feel like doing any work or more work than you have to, then make your calculator do the work. You want to add negative 9 divided by 2 plus 8. And you're like, oh, what's that? Then you hit the math key and press enter twice, and oh, there it is, pops out. You end up with 7 halves. So overall, your equation should look like y equals negative 9 halves x plus 7 halves. Yay. Let's take a look at the one down below. How has this one been shifted compared to the graph of x squared? What's the plus 5 do?
Left 5.
Left by 5. And
Down by 4.
down by 4. Wow.
That was easy.
Yes, nice. This one's been shifted to the right by 2 and up by 1. So this would be y equals x minus 2 squared plus 1. But this one's got a little bit more going on with it. So, Carvel, I think you finished figuring this one out. So what'd you get?
I got y equals negative, parentheses, x plus 3 squared minus 2.
Nice. Now, if you forget the squared, that's kind of a bummer because then this is a much different equation. You need that square, but you got it. So thank you so much. There you go. The negative flips it down. It doesn't affect how it's been shifted here or here. The negative only affects the direction that it's been shifted. All right, last but not least, we've got a house that's being built, permits and fees, a lot more than what was earlier. So let's see if we can't write an equation for that. I'll do it in X and Y. The 97,000, that's your B. We're going to put it in the form of y equals mx plus b. That's your fixed cost. So that doesn't change with the size of the house. So that's going to be $165 per square foot plus your 97,000. If you want to find the cost of building a 2,800 square foot home, what's that mean you're going to do? Plug in the 2,800. Somebody help me out. What number did you get there?
559,000.
559,000. Beautiful. And last but not least, if you wanted to figure out the square footage for a house that costs $575,000, maybe that's your budget, how would you start?
Plug it into your Y.
Yeah, plug that in for your Y. That's your cost. And then you figure out the square footage from there. 575,500 equals 165x plus 97,000. So if I subtract 97,000 from both sides, I'm gonna get what, 478,500 equals 165x. What did x turn out to be? 2,900, and units would be square feet. Awesome, awesome, well done. Comments or questions on any of those? How'd you guys do on these? Feeling pretty comfortable with this stuff? Make sure you do the homework and get ready for the quiz on Tuesday.